Actually, before we start chapter 3, I do want to say one thing. As a whole, as I drop the pen, as a whole across this class and the others, y'all's average and how y'all did on the test is better than it's been in years. So, I think the class averages last year were in the 60s or below, or around 60%. So, y'all did a lot better than it's been in years past. I think it's 80s. So there's still a handful that still need to take it, but again, y'all did quite well. Chapter 3 is quadratics. So we're still dealing with quadratics, or ax squared plus bx plus c. Now the first thing we're going to start talking about is factoring. Y'all have done some factoring. Factoring is really the reverse of the distributive property. So this is distributive. Because if we look at this first one here, 4x minus 5 times x minus 3. First thing we do is 4x times x. Well, 4 times the number in front of x1 is just 4. X times x is x squared. So we have 4x squared. Then we do 4x times negative 3. 4 times negative 3 is negative 12x. We'll do 4 times negative 3 is negative 12, and we still have the x. And that's all the terms with 4x. Then we'll do the same thing with negative 5. Negative 5 times x is negative 5x. And lastly, negative 5 times negative 3. Negative times a negative is a positive. 5 times 3 is 15. This is bringing back some memories of Algebra 1, a little bit in geometry. Last step's combine our like terms. 4x squared and 15 do not have any like terms, so we'll still have 4x squared. Negative 12x minus 5x, negative 12 minus 5, negative 17x plus. That's distributive property. And what we're going to be doing with factoring is we're actually going to start with our 4x squared minus 17x plus 15 and taking it back to our 4x minus 5 times x minus 4, or x minus 3. We're going to be going the other way around. That's going to be factoring. We can look at the other one while we're here. 4x times x, 4x squared. 4x times negative 4. 4 times negative 4 is negative 16, and we have our x. Negative 4 times x is negative 4x. And lastly, negative 4 times negative 4 is plus 16. Combine like terms. We'd have 4x squared. Negative 16x minus 4x is negative 20x plus 16. Questions on this here? So again, what we're going to be doing today is factoring. We're going from this standard form, this ax squared plus bx plus c, back to factored form. Now we're not going to worry too much with the a plus b times a plus b. If we did distribute it out, it would be a squared plus 2ab plus b squared. But what I want to focus more on is factoring. Factoring. Previously, you have factored polynomials of the form ax squared plus bx plus c. Y'all have done this before. We did it some in geometry. You did it most likely at the end of the year in Algebra 1. We did this here. The book doesn't do a whole lot of this here, so it's a lot with a being 1. We can have a different than 1. Now we do have some steps. Now, the ways to factor, there are many different ways to factor. The way that I'm going to go over and show y'all is the way that I find nicest, or I think is easiest to factor, or a nice way to factor. It does have a lot of guess and check. But the first step is pretty common across all of them. We want to find the GCF, the greatest common factor, and factor it out. We want to find the greatest common factor first if there is one. If there's a greatest common factor, we want to factor it out. Because removing that greatest common factor is going to make it easier to factor. So I'm going to be switching between this slide and the next slide. Luckily for y'all, it's on the same page. So if we look at this first one here, 5x squared plus 15x plus 10. Is there a greatest common factor between all three terms? And it is 5. So when we factor it out, we'll have 5 parentheses. Now when we factor something out, really what we're doing is moving it out front and dividing every term in the expression by that term. So since we factored 5 out of this 5x squared plus 15x plus 10, we're dividing every term by 5. So 5x squared divided by 5 would be x squared, because the 5 divided by 5 is 1. So we really have 1x squared, or just x squared. 15x divided by 5. Well, still be positive. We still have x. 15 divided by 5 is 3. So we have 3x. Plus 10 divided by 5 is 2. One thing I will say is whenever we factor something out, it will never reduce to 0. Because when we divide by something, the only way that we can divide two things and get 0 is if the top number, the number on top of the fraction, first number we're dividing by is 0. If the numbers are the same, it reduces to 1. Questions on first step? Anybody have a guess at step number 2? Because if we did distribute, we would actually get back to where we start. So our second step is to write 2, well, let's actually put right. You want to write 2 sets of parentheses with 3 spaces. 2 sets of parentheses with 3 spaces. That's fine. 2 sets of parentheses with 3 spaces. Yeah. So we'll still have the 5. The greatest common factor of 5 is going to be part of our answer. So with factoring, we're going to want to factor it back out. We're going to end up with 2 sets of parentheses. Now the main reason I say 3 spaces is to give us enough space to make sure we didn't put the parentheses too close together. And yes, those are all the steps. So that's why we have this here, because when we factor, we will have 2 parentheses, 3 terms, because we'll have 2 numbers or terms with variables and 2 signs. Questions on steps 1, 2, or 3? We're ready for step number 4. Huh? So now the next step normally for some is to find the factors. I think it's easier to find the signs. Now for when it's positive, it's not going to make a big difference. But if y'all remember back to Algebra 1 when we were finding the signs, especially for the third term when it's negative, because we had to have 1 and -4, -1 and 4, 2 and -2, -2 and 2, where we had all the sign differences for each one depending on what it was. I like getting rid of that first. And there's a way to do that, and that's what I do with step number 3. We want to find the sign. And by finding the sign next, we can mainly just focus on the factors, the number factors, not the sign factors. Now there's 2 cases. The first, if the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is positive, then the signs are the same and match the sign of the middle term. And there's actually some logic to this, because the terms are third term. If it's positive, well, the only way to get a positive number is if we multiply either 2 positives or 2 negatives. And our middle term we get from adding the 2. So the middle term really tells us what sign it is. The third term, if it's positive, tells us either it's positive or both negative. Kind of helps get that there. Now, if the third term is negative, well, that's how much we have to write for the positive. If the third term is negative, then the signs are opposite. All right, a whole lot if it's positive, but if it's negative, they're opposite. One's positive, one's negative, that's it. If the third term's negative, the signs are opposite. One's positive, one's negative. We don't even have to look at the middle term. It's just one's going to be positive, one's going to be negative. Questions on this here? So, let's look at this here. If the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. So the third term, is it positive or negative here? Positive. So the signs are the same and they match the sign of the middle term, which is, so they're both positive. It's a whole lot of words for not a lot of what we actually do. Would we agree with that? Yeah, it's a whole lot of explaining for not a whole lot. But questions on steps 1 through 3. Are you ready for step number 4? We're going to find the factors of the first and third term. No real reason why I switched from words to numbers. Factors of the first and third term. Now, if we look at this here, the first term is what? X squared. What are the factors of x squared? What things multiply together to give us x squared? X and x. Is there anything else? Well, no. I mean, there's 1 in x squared, but that doesn't work for this here. So the only factors of x squared that we have are x and x. Put these here. Might as well just plug it in, x and x. The only way that it won't be x and x in those first two spots is if x squared's in the third. Because if x squared's where the 2 is at for this here, they wouldn't go in the first place, so they would go in the third spot. That's the only real difference. All right, well, that's the only factors for x squared. Our third term is what? 2, yes? Well, what are the factors of 2? 1 and 2, I'll write the factors of x squared. But our only factors of 2 are 1 and 2, yes? All right, we're just going to stick them in. Where do you want to put the 2? In the first set or the second? First one. First, second. So I'm going to come back to it. Because our last step, and we've kind of already started this, is to plug in and check. Because we already did the plug-in part. We picked the factors, which ones we want to try first, and we plug it in. Plug it into the first spots, plug it in the second. And the last part is to check. Now, most textbooks, and most will say, if we check this, the first thing we'd have to do is multiply x and x. I find this to be a little redundant. Because x times x is what? X squared, yes? Where do we get x and x from? The factors of x squared. By definition, they multiply together to give us x squared. So is there a whole lot of reason to check those? No. The other one I find a little redundant to check is 2 times 1. 2 times 1 is what? 2. Where do we get 2 and 1 from? Factors of 2, yes? By definition, they should multiply together to give us 2. I don't ever check those sets, because that's where we got them from, yes? The ones I'm checking for is the middle term. Where we get this term from is our x times 1 and 2 times x. This is the one that, depending on the factors, will change. First and third aren't going to. Here, x times 1 is 1x, or x, positive x. 2 times x is positive 2x. And x plus 2x is that the middle term we wanted? And since it is the correct middle term, 5 times x plus 2 times x plus 1 is the correct factored form for this here. If we got a different middle term, we did not get the correct middle term. We'll start switching the factors, either the third term or the first term, till we get what we want. We get the correct middle term. Questions on this here? And the more of these that you do, obviously the better you'll get at, but the more you'll see the patterns and see how these work and know which ones of the factors are more likely to work than others. Questions on this here? Are we ready for the next one? And luckily, the next one's going to go a little bit quicker. 4x squared plus 32x plus 60. Step number 1. Is there a greatest common factor between these three terms? And the greatest common factor is 4. And really what we're doing is dividing all three terms by 4. 4x squared divided by 4 is x squared. Plus 32x divided by 4. It would be 8x. Plus 60 divided by 4 is 15. 15. Questions on step number 1? We're ready for step number 2. step number 2 is 2 sets of parentheses with 3 spaces. All right, that takes care of steps 1 and 2. Step number 3 is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. What's the sign of our third term? Positive. So the signs are the same, and they match the sign of the middle term, which is positive. So both of our signs are positive, or plus and plus. Questions on this so far? We're ready for step number 4. Find the first and third term, and then we're going to plug them in. So the factors of our first term, factors of x squared, well, we only got one of them, which is x and x. And that's it. Because really the number in front of x is 1, so with 1x and 1x, or x and x. Those are the only factors, so we'll just plug them in and not worry about that. 15, on the other hand, does not have one set of factors. We have 1 and 15. 3 and 5. 2 does not work, but 3 and 5 does. So now we have 2 different sets of factors, unlike the first one where we just had 1 and 1. So the question is, which one do we want to try first? 1 and 15 or 3 and 5? 3 and 5. Does it matter really where we plug the 3 and 5? No. You just need to plug them in. We need to pick a set of factors for 15 and plug them in. And the reason the order or which one we pick really doesn't matter too much at this point is because of step 5. The last part of step 5 is to check. Here, again, I'm not too concerned with x times x or 3 times 5 because we got x and x from x squared, so it's going to go back to x squared. 3 times 5 is still 15. That's where we got 3 and 5 from. The main one we're going to focus on is our x times 5. X times 5 is positive 5x. And our 3 times x is positive 3x. And 5x plus 3x is 8x. Is that the middle term we wanted? So the correct answer is this here, 4 times x plus 3 times x plus 5. Questions on this here? I'm going to change it just for a second. Say I chose 1 and 15. If we chose this here, well, our x times x is still what? X squared, yes? 1 times 15 is still, even though I picked the other ones, it still gives me the first and third term, yes? Let's look at the middle term. X times 15 is now 15x. 1 times x is plus x, giving us 16x. A little too much. Even though the first and third terms didn't change, the middle term is different. That is why I only really check for the middle. The first and third are going to be the same. They're the factors from the first and third term. No reason to check them. X times x, 3 times 5. But we do need to check for the middle one. It changes depending on how we have it set up. Are we ready for the next one? All right. Let's dive right in. 4x squared plus 13x plus 3. Greatest common factor is 4, yes? No, it's not, because 4 does not divide into 4x squared, 13x, and 3. It's 1. We can factor 1 out. If I factor 1 out of 4x squared, we end up with 4x squared. If I factor 1 out of 13x, we end up with 13x. And if I factor 1 out of 3, we end up back with So it doesn't do as much of anything. So is there a greatest common factor? No, there doesn't have to be. It's nice if there is, but if there's not one, well, we move on from step 1 to step 2. We go to our 2 sets of parentheses with 3 spaces, because if there is one, it does help us. It makes it a little bit easier to work with. If not, we just move on to step number 2. 2 sets of parentheses with 3 spaces. Now that takes us to step number 3, define the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the third term is positive. So the signs are the same and match the sign of the middle term, which is also positive. So we have plus and plus. All right. Factors of the first and third term. Factors of the first term, 4x squared. Well, the x squared, we know we'll have x and x. There's a few reasons I do that, but the main one, most important one, well, 4x squared, if we looked at its factors, well, it would be x times 4x and 2x times 2x. Well, of all these here, x times 4x, 2x, I mean, we have x and x in each spot, yes? Well, we know x and x is going to show up. So instead, get rid of that. Just lets us look at the factors of 4, which is 1 and 4, or 2 and 2. If we have less things that we have to work with, I am all for it. Because x and x is going to show up in both, so why not just look at the factors of 4? 1 and 4, 2 and 2. 2 and 2. Factors of 3 are 1 and 3. Where do we want to put the 3? First set of parentheses or second? Second. So we'll put the 1 in the first, 3 in the second. And then we will check. Don't have to check 2x times 2x because that's still 4x squared. Or the 1 times 3 because that's still positive 3. 2x times positive 3. 2 times 3 is 6x, or 6x. 1 times 2x is plus 2x. And 6x plus 2x is 8x. Is that the middle term we wanted? No, we wanted 13x, yes? So the first step from here, we can switch the 1 and 3. That's normally the first place I'd go. I wouldn't so much do it here. I'll show. Okay. Place. Because if I switch the 1 and 3, we get what? Same thing. 2x times 1, 3 times 2x. So we might not. So switching the 1 and 3 really doesn't do much. So what will we need to switch? We'll have to switch the 2 and 2. Because even if we switch the 2 and 2, we get back to where we are. It doesn't really change. So we'll have to go to 1 and 4. Where do you want to put the 4? In the first or second? Second. And we put the 1 in the first one. We can write 1x or just leave it as x. And we can check this here. X times 3 is 3x. 1 times 4x is plus 4x, giving us 7x. Is that the middle term we wanted? What do we want to switch this time? Yeah, we can switch the 4 and 1. 4x and 1. We can check it again. 4x times 3 is 12x. 1 times x is, and 12x plus x is indeed 13x. Questions on this here? And as I said earlier, the more that we do, the better we'll see these. We'll see which factors are probably going to work better than others. And we can try checking them first. Now, some don't like this kind of method because, as you all have noticed so far, there is a lot of guess and check. But as we do this, we'll start discovering some patterns that will help us eliminate possibilities quicker. Let's look at this one here. 3x squared minus 7x plus 2. Is there a greatest common factor? No. So we'll move on to step number 2. 2 sets of parentheses with 3 spaces. We're going to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So here the third term's sign is positive. So the signs are the same and match the sign of the middle term. What's our middle term? Negative, so our signs are both negative. Because to get that third term, we would be multiplying these two here, yes? Well, a negative times a negative is a positive. That's why this works. In the middle term, we add them together, so we'd add 2 negatives, and it'd stay a negative. We good to this point. Now we need to find the factors of the first and third term. Well, our 3x squared, we know part of the factors are going to be x and x. Factors of 3 are 1 and 3, 3 and 1. Where do we want to put the 3? We'll put it in the first one. If you want to write 1x, you can, or you can write x. Either way works. Factors of 2 are 1 and 2. Where do you want to put the 1 and where do you want to put 2 first? 1 in the first one, 2 in the second, and then we can check to see if this works. 3x times negative 2x is negative 6x. Negative 1 times x is negative x. So we have negative 6x minus x is negative 7x. Or we can really say negative 6 minus 1, negative 7. Is that the middle term we wanted? Yeah. So sometimes it does work out nicely where we pick the correct setup first. It checks out and we're done. Sometimes we have to switch things around. Questions on this here? We good so far? Kind of, we're getting there. We'll do more of this. We're going to be doing a good bit of factoring. Let's look at the next one. Are the slides out of order? Okay. 2x squared plus 7x plus 6. Is there a greatest common factor? No. I mean, 2x and x squared and 6 have a common factor, but not all 3. It has to be across all 3. So we'll move on to step 2, our 2 sets of parentheses with 3 spaces. Third step's to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Here, the third term is positive. So the signs are the same and they match the sign of the middle term, which is positive. So we'll have plus and plus. Now we're going to find the factors of the first and third term. Our factors of 2x squared, well, we know we'll have x and x. Factors of 2 are 1 and 2. Where do you want to put the 1? Where do we want to put the 2? 2 in the first, 1 in the second. Now we need to find the factors of 6. 1 and 6 or 2 and 3. Which one of these do we want to try first? The 2 and 3, yes. Where do you want to put the 2? Where do we want to put the 3? 3 in the first, 2 in the second. And we can check. 2x times 2. 2x times positive 2 is positive 4x. Positive 3 times x is going to be plus 3x. 4x plus 3x is that the middle term we wanted? Two x plus 3 times x plus 2 is the correct answer. Questions on this here? I'm going to switch it around just for a little bit. Now we know that is the correct answer. Now if I wrote it as this here, and I checked it, 2x times 3 is 4, or 2x times 3 is 6x. 2 times x is plus 2x. That gives us 8x. That's not the correct term. Okay. I feel like the board just jumped around. So we can see that this is not the correct answer, yes? Look at the first set of parentheses here. 2x plus 2. Is there a greatest common factor? Did we say that there was one to begin with? One of the nice things with this is if there's not a greatest common factor to begin with, there can't be one in either set of parentheses. Because if the 2x plus 2 did work, well, technically I could factor that 2 out of that set of parentheses. Does that make sense? Kind of. Now, if it doesn't, that's fine, because again, our check step tells us it doesn't work. But what that tells us is that the number that goes here cannot be 2 or 6, because 2x and 6 have a common factor of 2. That gets rid of some of the possible factors that we can have, or possible setups. Because if we can get rid of possible arrangements, it makes the number of ones we have to check smaller. But if that doesn't make sense and we don't see it, that's fine, because again, we can still check and get there. Does that make sense? Yeah. I'll pick this up tomorrow.